A problem so complex it was meant to take 10,000 years to solve, China just did it in seconds. Quantum computing is no longer a far-off theory, it's here, and China has just taken the lead. For decades, quantum computing existed at the edge of science fiction, a tantalizing possibility that, if achieved, could reshape technology, security, and global power. The idea was simple: a machine that could process information at an exponential speed, solving problems that even the best classical supercomputers couldn't handle. In 2019, Google's Sycamore processor shocked the world by performing a calculation in 200 seconds that was estimated to take a classical computer 10,000 years. But just as the world was beginning to grasp that achievement, China arrived with a bigger claim, one that has now rewritten the quantum landscape. Their Zhuhang quantum computer didn't just match Google's milestone, it obliterated it. The calculation involved a problem known as Gaussian boson sampling, GBS, a complex mathematical challenge simulating the behavior of photons in an optical network. In practical terms, it doesn't yet crack encryption, cure diseases, or revolutionize AI, but it proves something far bigger: quantum computers are no longer just a theory, and China might just be leading the charge. So, how big is this leap? Google's Sycamore solved a random circuit sampling problem in 200 seconds, initially believed to take 10,000 years on a supercomputer, later corrected by IBM to be just 2.5 days. Zhuhang, however, performed a far more complex task, one that would have taken 2.5 billion years on a classical machine. That's not just an improvement, that's an entirely different scale of computation. For the first time, quantum supremacy isn't just a headline, it's a reality. What does this mean for the world? Is China now ahead of the West in quantum technology? Does this signal the start of a quantum arms race? And perhaps most importantly, how soon before quantum computers start solving real-world problems? The answer: sooner than we ever thought. In October 2024, Chinese researchers made headlines by claiming they had used a quantum computer to breach SBN structured encryption algorithms. The machine in question was a D-Wave Advantage quantum annealer, a system designed for solving optimization problems rather than performing universal quantum computations. This revelation sparked widespread debate about how close China might be to breaking widely used encryption standards like RSA 2048. Quantum decryption has long been a looming concern for governments, financial institutions, and cybersecurity experts. Modern encryption methods rely on mathematical problems that are practically impossible for classical computers to solve within a reasonable time frame. However, quantum computers, with their ability to perform certain calculations exponentially faster, could one day crack these cryptographic systems, effectively rendering today's cybersecurity infrastructure obsolete. If China were to achieve this before the West, it could gain unprecedented access to encrypted communications, financial transactions, and even classified military intelligence. This would mark a fundamental shift in cyber warfare, giving the country a major strategic advantage in global geopolitics. However, while the 2024 breakthrough is significant, it does not yet indicate that China has achieved quantum decryption on a scale that threatens RSA encryption. RSA 2048 is one of the most widely used cryptographic standards, securing everything from online banking transactions to military and government communications. The security of RSA encryption is based on the difficulty of factoring large prime numbers, a problem that is computationally infeasible for classical supercomputers to solve within a practical timeframe. In theory, quantum computers could crack RSA encryption in seconds, but in practice, no existing system is anywhere close. Despite the attention surrounding China's 2024 breakthrough, it is important to recognize the technical limitations of the method used. The D-Wave Advantage quantum annealer, while impressive in its optimization capabilities, is not designed for breaking RSA encryption. Quantum annealers are specialized for solving combinatorial problems such as logistics optimization, but they do not operate in the same way as gate-based quantum computers, which are necessary for running Shor's algorithm. Additionally, breaking RSA 2048 would require a fault-tolerant, error-corrected quantum computer with millions of high-quality qubits. At present, no such system exists. Even Google's Sycamore processor, which achieved quantum supremacy in 2019 by solving a random circuit sampling problem in 200 seconds, operates with just a few hundred qubits. IBM's latest Condor quantum processor, announced in late 2023, has over 1,000 qubits, but it remains far from the scale needed for large-scale decryption. Another challenge is quantum error correction, which is essential for sustaining quantum calculations over extended periods. Quantum states are highly fragile and prone to decoherence, meaning that without significant advancements in error correction, today's quantum computers are unable to maintain stability long enough to factor large numbers. Until researchers can implement a scalable error correction framework, quantum decryption of RSA remains a theoretical threat rather than an immediate one. While China's progress in quantum computing is undeniable, its ability to break RSA encryption remains limited. The recent achievement suggests that Chinese researchers are actively working toward quantum decryption, but the technology is still years, if not decades, away from posing an immediate risk to global cybersecurity. The US, EU, and other major powers have already begun preparing for the quantum threat by developing post-quantum cryptography, new encryption methods designed to withstand quantum attacks. The National Institute of Standards and Technology, NIST, has been leading efforts to standardize quantum-resistant algorithms, which are expected to replace RSA encryption before quantum computers become powerful enough to break it. China's rapid advancements in quantum computing have triggered a new kind of arms race, one fought not with missiles and warships, but with algorithms and supercooled processors. While the world has long been aware of the coming quantum revolution, Beijing's latest breakthroughs have forced Western governments, military strategists, and intelligence agencies into overdrive. This is no longer just a race for scientific prestige, it's a battle over who will control the future of cybersecurity, military dominance, and economic power in the quantum era. Quantum computing is not just a cybersecurity issue, it has direct military implications, and China knows it. One of the most alarming developments is China's progress in quantum radar. Traditional stealth aircraft, like the F-35, B-2 bomber, and future US drone fleets, rely on their ability to evade detection using radar-absorbing materials and electronic countermeasures. But quantum radar, powered by quantum entanglement, could allow Chinese defense systems to detect and track stealth aircraft with unprecedented precision. This could render US and NATO stealth technology obsolete, forcing Western militaries to rethink their air combat strategies. Beyond radar, quantum AI-powered military simulations could give China a huge strategic advantage. Quantum-enhanced AI could run real-time battlefield simulations, allowing Chinese military planners to predict and counter enemy moves before they happen. These simulations could also optimize drone swarms, missile defense systems, and cyber warfare strategies. The Pentagon, NATO, and Western defense agencies are now scrambling to integrate AI and quantum computing into their own military strategies. Projects such as DARPA's quantum research programs and the UK's National Quantum Technologies Programme are being fast-tracked to ensure that the West does not fall behind. A quantum Cold War has begun, and the next decade will determine which superpower, China or the West, will dominate the quantum revolution. The question isn't whether quantum supremacy will change the balance of power, but who will control it first. Please like, share, subscribe and comment. Thank you for watching my channel.